This is the world's most advanced 40-story tall, 5,000-ton rocket blasting into outer space. And this is my rocket, set to launch in that exact same way in 10 minutes from now.
1.
But before I get into that explosive launch, I need to show you what went into the 2-month journey that led to this moment. Because while both of these rockets use similar principles and are very complex, the difference is that you'll get to see every step behind my rocket's science and creation. So if you've ever wondered how rockets are actually constructed, the fascinating science behind them, and how they're shaping our future more than ever, I broke it all down into this fun yet informative 3-part crash course, ending with the launch, starting with step 1, the nose cone. I haven't built it yet, so this is kind of awkward. But luckily for me, this part came fully assembled. And you'll notice that if you look at it from the side, it makes almost a perfect parabolic shape. But why does it look like this? How does it help the rocket, and is it edible? The first clue I found while solving this mystery was that as rockets blast off, they have to push through millions of tiny air particles blocking their pathway up. We call this air resistance that slows down the rocket drag, which is represented by this formula. But because math scares me, a much easier way to visualize it is by first imagining you're jumping into a pool. If you're trying to cover the most distance possible while minimizing damage, you don't want a belly flop because nobody wants to hear the sound you make, and it would be way harder to push through all of those molecules with such a wide surface area. However, if you instead assume a pointier shape, you'll make a much prettier noise and can displace the molecules easier. Therefore, since air behaves like a fluid, these pointier shapes allow the rocket to shoot up with the least resistance and damage, protecting its valuable equipment and covering the most distance possible. Which is why almost every rocket you see assumes this parabolic shape. And before I get to the launch where so many things went wrong, let me introduce you to section 2, the upper body tube. I still haven't built it yet. As you can see, this part of the rocket sits just below the nose cone and plays a really important role. Not only does it connect both halves of the rocket when it splits in half mid-flight, but it houses the payload. But the one I used isn't on this list and is super funny, which I'll reveal in a bit. Because this equipment is fragile, it's really important that you engineer it correctly to protect it. And all that's left to do is reveal what I used for my payload, which was my homework. And to quickly transition before I get expelled, it's finally time to move on to the lower body tube. This section holds 3 critical parts that I'll tackle one at a time, starting with the fins. First, picture a rocket. You probably imagined a long pointy tube attached to 3 large fins. But why do rockets have these fins? A good way to understand this is to first imagine you're trying to balance a pencil vertically on the tip of your finger. It's pretty difficult, right? This scenario is very similar to trying to balance a rocket upright as it's shooting in the air, which raises the next question. If it's so hard to balance this pencil, how do rockets stay pointed upright? And that's where the fins come into play, because balancing a pencil replicates 2 of the major forces that a rocket experiences while blasting off: an upward force at the bottom from your finger, or the rocket's engine, and the downward force of gravity. However, during flight, there's a secret third force at play. Do you remember that inconvenient air resistance or drag force from before? Well, engineers cleverly use this inconvenient force to their advantage to keep the rocket upright, because from this angle, you can see that as the rocket starts to tilt, suddenly a larger area on one of the fins becomes exposed from above. This larger area experiences a larger downward force than the other fins do, which causes the rocket to rotate back into that upward position. But why are these fins located at the bottom? And the reason for that is because as every object travels through the air, they have a pivot point at their center of mass that they rotate around, which is located here on my rocket. But if the fins were located at these points, this would happen. This is exactly why fins exist and why they're located at the bottom of the rocket. I feel like I should drop this mic, but I don't want to break something. I then epoxy glued them onto this engine holder. Just like me, it's not pretty, but it gets the job done. Which is a great segue into section 2, the engine. Getting my rocket's engine was the hardest part of my dream, because there are so many different rocket engines that influence its flight differently. This is why simulating the flight using different engines is so important, which involves following these steps, and after much consideration, I finally settled on the H100W. This is awkward because I still have to get it. And as I'm driving, I'll explain the 3 main ways in which rocket engines differ, which are conveniently represented in their names. The middle section is the engine's average thrust, which is related to its impulse and is basically how high it can go. The next section is its impulse categorization, ranging from A to O and doubling as you move up the scale. But this also means that the engines double in power, and this is why engine companies group the strongest engines into 3 levels and require a successful launch at each level in order to move on to the next one. I then slid the engine in place place by creating this motor mount here, which holds the engine up and hooks onto the parachute cord, which is a great segue into our final section, the parachute recovery system. I mentioned earlier that my rocket's gonna split in half, but I bet you're wondering why. And it's to deploy their crafty parachute recovery systems. The parachute is stored in the middle of the rocket and is connected to both of its halves, so when it separates, all pieces come back down safely. It deploys at the peak of a rocket's launch when a secondary miniature explosion occurs inside of the rocket, creating so much pressure that both halves split in half, leaving the parachute with no choice but to be caught by the wind and deploy. But it's important to time this at or before the peak of its launch when it's moving the slowest, so it doesn't get caught by the super fast wind and break. But how does the rocket know when to split in half? This separation is timed by drilling into the engine. However, I could only delay mine in imprecise 2-second increments, which was a problem later. And finally, it was launch day, and all that was left to do is answer this question.
Are you ready, Colin?
Yes.
Here we go.
But before I blast off into this launch like a rocket, get it? I need to explain why I built it in the first place. Do you remember that rocket level system from before? Well, I'm actually launching this rocket using a level 1 engine in order to earn my certification and level up to use stronger ones, which will be the stepping stones I need to get into the space industry. But why spend money on space when we have so many problems here on Earth? You've probably heard this question before, and before I give you 2 strong arguments for that, you need to first understand how much of the federal budget is actually spent on NASA in the first place, which is less than 0.5%. So now that you understand how little is spent, here are 2 strong arguments for why investing in space is so important. Reason 1, to improve life on Earth. My favorite way to picture space is to compare it to Earth's vast oceans. Back in the day, people definitely argued, why build ships when we have so many problems here on Earth? But without taking that leap, we wouldn't have done any of these incredible things. Space exploration works that exact same way, except instead of a continent waiting to be discovered, it's an infinite amount of land, resources, and mysteries just beyond our reach. Additionally, a ton of inventions have already resulted from space investments, which make our daily lives so much better, including GPS, satellites, and all of the things on this list. And all of this was done by spending only half of that penny. Imagine how much better our lives would be if we invested even a little bit more. My second reason for why investing in space is so important is because it gives us so much hope. Without putting effort into understanding space, we wouldn't know that the Earth is round, how many planets make up the solar system, and that galaxies beyond our own exist. Additionally, this NASA image was taken when astronomers pointed the Hubble telescope at the darkest region in our night sky. And every speck of light you see besides these 3 marks represents a galaxy filled with billions of stars, which takes up the space of Franklin Roosevelt's eye on a dime held at arm's length. With so many galaxies and planets out there, the chance that we're alone in this universe is infinitesimally small. And all that stands between us and discovering it is putting just a little bit more effort into space exploration, which already makes our daily lives so much better. And this is exactly why I care so much, why I've dedicated my life towards the field, and why I built this rocket. However, none of that will matter if my rocket doesn't successfully complete these things, because it's the only way I'll get certified and get the experience I need to step into this field. After months of hard work and a lifetime of dedication, I only have one shot. There are a million things that could go wrong, but everything has to go perfectly.
Are you ready, Colin?
Yes.
Here we go. And 3, 2, 1.
No. Oh my god. That was scary. It actually did the parachute. Everything was going perfectly. That was until this happened. Oh, it went in the trees. Which was a huge issue because the only way I'll get certified and for any of this work to matter is if I'm able to somehow find it. I see it. And bring it back to the judges in one piece. But then this happened. I have good and bad news. The bad news is I couldn't find the parachute anywhere and I'm really worried. But the good news is we were able to get the rocket back. And all that was left to do was see what the judges thought. I've made it.
Looks like a rocket to me. Okay, but you need it.
Thank you. And there you have it. After this long, hard journey, I finally earned my certification, a ton of engineering knowledge, and so many memories with the amazing people who supported me along the way. I hope this video taught you a ton about engineering and why space is important, but most importantly, I hope this shows you that no matter how crazy our dreams may seem, even when it feels like there's a dense forest filled with sticks and bushes standing between you and your goals, as long as you don't give up, chase after them, and and take those first steps into that dense forest. While it's not going to be easy and you might even get pricked along the way, you'll certainly reach them. And even if you don't right away, you'll definitely get a lot closer to them, and who knows, maybe you'll enjoy where you end up even more than where you initially sought out for. But I think I'm forgetting one last thing. No, my homework's still in there, I still have to do it.